All right. So I think everyone is here now. So let's start the interview session now, Ken.
Yeah,
So first of
can.
first of all, a very good evening to our beloved interviewee, Mr. Mathiyazhagan and Hakim Muneesamy, who work as the Senior Manager Operation Chief at Tuanku Power Station, TMB Power Generation, Sdn Bhd, and all my fellow group members. We'd like to express our gratitude to you, Mr. Mathia, for accepting the invitation for our interview session. We are the students of Diploma in Mechanical Engineering from University of Tun Hussein All Malaysia, or simply known as UTHM. My name is Chan Junwei. I'm the leader of Group 2 for Thermodynamics interview session project. Please allow us to introduce ourselves before we start. Here we go with the first members.
Hello, Mr. Mathia. My name is Ahmad Syahidi.
Ahmad Syahidi, yeah?
Yes, Mr. Mathia.
Okay.
Hi, Mr. Mathia. My name is Nabila.
Amirah?
Yes.
Amirah, okay.
Hi, Mr. Mardia. My name is Minchi.
Yeah, okay.
So may we start our interview session now?
Yeah, first of all, it's glad to see you all, and thanks for choosing me lah. I don't know why me, but okay, I'm in the line, so I think you have chosen the not to say right person, but I'm in the line anyway. All right, maybe this session will help you very much in your project, and please do ask question. And maybe this is not the first one. Maybe we have to follow up to if you want to have a better understanding. This maybe 1 hour session is not enough. Definitely not enough. I myself more than 20 years still not yet smart, still learning. Okay. All right. Okay, I pass it back to you.
Okay, so now I will start with our first question. So may I know what is your company main business?
Okay, basically TNB power plant. I mean TNB, we have 4 division basically. Yeah, used to be 3, so now 4. Okay, we have generation. We have grid. Grid mean transmission. You know, transmission. The power line by the roadside. You have seen, right? That is a grid. Grid network. Okay. Then we have distribution and also retail. Okay, that's 4 TNB. So myself come under generation. Now we call Genco. Generation power generation Sdn Bhd. Okay, Genco. Then our business is of course generation. We generate power. Okay, so we only generate. We generate power. All the power plant we generate power, and the output we send to grid. Okay, that's our boundary. So we generate power. It can be 250 megawatt. It can be 750 megawatt. It can be 1000 megawatt. Okay. So like our power plant in Port Dickson, we have phase 1 and phase 2. Phase 2 we are producing 750 megawatt, and phase 2 another 750 megawatt. So altogether 1500 megawatt. Okay. Phase 1 we have 3 generators. Okay. Phase 1 we have 3 generators. 2 gas turbine and 1 steam turbine. And also PD2 we have 3 generators, 2 gas turbine and 1 steam turbine. Okay. So phase 1 250 megawatt, 1 gas turbine, the another gas turbine to another 250 megawatt, so 500 megawatt, and steam turbine another 250 megawatt, so 750 megawatt. It also goes to PD2, phase 2, 750 megawatt. Okay. So PD here we call it combined cycle power plant. Okay. we have gas turbine, we have steam turbine, we have coal power plant, we have nuclear, we have Malaysia don't have nuclear. So we have nuclear power plant, we have hydro power plant, wind turbine, and but in PD, in Tuanku Jaffa, we call it combined cycle power plant because we have gas turbine and we have boiler and steam turbine. That's why we call it combined cycle power plant. If only gas turbine itself, we call it a simple cycle power plant, simple cycle or open cycle. Okay. Am I answered your question, Miss Yi? Or you need more
Okay.
further? No problem. You can ask more. No problem.
Oh, never mind, never mind.
Yeah.
Thank you, Mr. Madia, and I will continue with my second question. What are the major components that are applied for electricity generation in the power station?
Okay. For generation, basically to generate. You're asking about Tuanku Jaffa or in general?
In general.
In general. Okay. Let's say to produce power, to generate power, we must have the small one we call it dynamo, right?
Yes.
Okay, in our case we call it generator. Okay, we have generator where we have stator and rotor. Okay, uh, uh, you understand? We have where the magnetic flux cuts, then only we will have the voltage, right? You have learned that, right? I mean the generator.
Yes.
Okay, so to rotate the rotor in the generator, we need another mechanism, right? So that is turbine. Okay. Wait. Oh wait, I changed the.
It's okay if Mr. Matia want to present the screen. We're okay with this.
No, actually, I want to draw.
Oh, draw. So,
Yeah,
draw.
I want to change the background.
Oh, okay, okay.
Wait. Okay, this background is. Okay, 1 minute. Yeah, 1 minute.
Okay, Mr. Matia, okay.
Can you see this?
Yes, Mr. Mathia.
Okay, this is what we call roto. Okay, roto, and this is stator. Okay, so if like that mean, okay, so this one rotates. Okay, this one rotates. Okay, this one rotates. This one don't rotate because stator, stationary. Okay, so when this one rotates, the magnetic flux cuts, and we get the voltage. That's a current output we need lah. Okay, okay. To rotate this, we need another mechanism. So there we have turbine. Okay, turbine. Okay, to rotate turbine, we need another energy to rotate the turbine. So where there is the combustion gas turbine. We have combustion, and this the gases. After combustion, the gases come through here and rotate the heat the blade. The blade connected to the shaft. The shaft rotates and rotates the dynamo. Very clear? Okay, so we have generator, we have turbine. In case of gas turbine, this is simple cycle, very simple. Okay, and of course we have many things here. It's not simple as simple as this. So we must have fuel, we must have air. Okay, here combustor, we must have fuel, we must have air. Okay, air is oxygen lah, and we must have fuel, and of course spark. Okay, spark. Then continuous 24/7, and maybe to 11 months no stop, the flow will be running. Okay, so this is simple cycle. Okay, so when this rotates, this one rotate, so we have output megawatt, 250 megawatt. Okay, all right. So the temperature here is 1400 degree Celsius for Tuanku Jaffa power station. Almost plus minus. Okay, and what happened? Oh, no, sorry. Sorry. Wrong. Here. The turbine supposed to be this way. Okay. This is for what? This is for compressor. Okay. Must know this is turbine and this is compressor. Compressor inlet here, outlet here. Turbine inlet here, outlet here. Clear? Okay. So 1400 degrees Celsius is here. So once work done, thermodynamic, you know, right? You have learned all that, right? Okay, once done, this is the exhaust. Exhaust is 650 degrees Celsius. Okay. Got energy or not? Hot or not?
Hot.
Hot, eh? So it is a waste if we discharge to the atmosphere, right? Okay, what we will do? We will channel these to boiler. Channel these to the boiler. We don't call it boiler, we call heat recovery steam generator. Okay, heat recovery steam generator. Okay, here we heat up water, convert into steam, and that steam we send to steam turbine. Okay. Okay. Okay, gas turbine. Then HRSG, heat recovery steam generator, or we call it boiler. Boiler, boil water here. Okay, 680 degrees Celsius. Go inside here. Boil the water. Come out steam. Steam goes to steam turbine. Steam turbine. Same, This is gas turbine, and this one is steam turbine. Rotate the generator. We got output here. Another 250 megawatt. Okay. So then the steam will be converted into water inside condenser. Then pump back to the boiler. It's like that. Okay. So this one we call it open cycle. Gas turbine only we call it open cycle. The whole thing we call combined cycle power plant. Okay. So to answer to Yi punya question, so we have gas turbine, we have HRSG, heat recovery steam generator. Then we have steam turbine. Okay, this is combined cycle. This is the major component. Okay, so of course we have condenser, we have many more components, but this is the main. All right.
Okay, thank you, Mr. Mardia.
Okay.
And I will pass to Ahmad for the next question.
Okay.
Okay, Mr. Mathia. For the third question is, what are the manufacturers of these components?
Okay. The manufacturer of this component, as I told you, we have phase 1 and phase 2. Okay. Phase 1, the manufacturers is Mitsubishi Heavy Industry, MHI. Okay. All the three. That means the gas turbine by MHI, the heat recovery steam generator by MHI, and the steam turbine also by MHI. Okay. Whereas the PD2 phase 2 by the gas turbine is by GE, General Electric, and the boiler or the heat recovery steam generator by Nutter Ericsson, and the steam turbine by Toshiba. Yeah.
Okay, thank you, Mr. Mathia. Next question. What are the basic working principles of these components to generate electricity?
Basic principle.
Yes.
Okay, basically ours is a thermal power plant. Okay, thermal power plant, and it is using a Brayton cycle for gas turbine, and also Rankine cycle for steam turbine. Okay, so where we have pressure, temperature, same goes to steam turbine also lah. If you have of course thermodynamic, we studied Brayton cycle and Rankine cycle, Carnot cycle, and all that, right? So that's the principle that we use. What else? Am I question? Am I answered your question? Very. I think very general.
I think the basic principle that Mr. Mati already answered with E. Just now E asked the questions. Already that is already considered as a principle of how do we generate the power, electricity power. Yeah.
Yes.
So I think this question is already answered. So can we proceed to the next questions?
Can, no problem.
Okay. So because we're trying to make it faster by not exceed 1 hour.
No problem.
Okay.
Okay, thank you, Mr. Mathia. Next, I will continue the interview session with the fifth question. I'm curious about the type of system being used for electricity generation. Can you explain about it?
Again, I didn't get the first part.
The type of the system being used in electricity generation.
Type of system.
Yes.
I thought I already answered by drawing the schematic just now is already answered, but how to better understand your question, or is there any detail you want to know? System? What do you mean by system? So we have many system. We have fuel, we have water, we have gas. Okay, so definitely we by gas turbine we need gas. Gas is our main fuel. Okay, and we have we need air system. Air mean the atmospheric air. So where we filtered it and sent to the combustor. Okay, and also gas from Petronas, and we send to the combustor. So that is one system for the gas turbine. Okay, and on the boiler side we need water, and our water is not the normal water. Okay, normal water, yes, we got it from Jabatan Bekalan Air, wherever, like Negeri Sembilan we call it science. In your place, I don't know, Lembaga Urus Air Johor or what lah. It's like that. And okay, we get from the town water. So we demineralize the water. Okay, demineralize, we cannot use normal water. Okay, so we have to demineralize. That means our boiler water got nothing, is a zero, no mineral at all. So that is water system. Then many more. We have chemical, we have chemical injection, and we have a cooling system. Okay, cooling system. We need we use at condenser. So to convert the steam into water. You know how the condenser work, right? Okay. So that is water, cooling water system. So with all that, we generate power lah. So not very clear. I think your question is very general. I also do not know how to answer that. But these are all the system we involve lah. And also oil, lube oil, lubrication oil, and all that. I don't know whether it's a smart answer or not, but I feel I didn't answer your question, but I don't know what to do.
Never mind, Mr. Matthias. So
Yeah.
because we are only in diploma studies, so I think no need to be complicated.
Yeah.
Just basic. As long as we know how the system is working,
Yeah.
and that's all. That's enough for us. So that can I pass back to Amirah? Okay.
Okay, Mr. Matia, I think my next question is about working fluid. So you have already explained about it. So I want to ask about the selection criteria of the working fluid.
Selection criteria.
Yes.
Okay. Actually, it's the selection of power plant basically lah. Not the fluid yet. Okay. Selection of the power plant itself is very important. Okay. If you want to have gas turbine, okay, if you are in the desert or if you are in the center of KL city, okay, you can have gas turbine, open cycle. You know Putrajaya, right? Putrajaya, we have 5 gas turbine. It's an open cycle. Okay, why? Because the gas turbine is very simple. Okay, you can erect very fast. Okay, you import the thing, you construct within a few months. You can construct and you can generate the power. Okay, because compact, easy, less space. Okay, yeah, this is your criteria, Amirah. Yeah, this is the criteria. Okay, less space, very fast, and okay, very fast, easy to operate. We need few people, operators, so we don't need many people. It's only one button press, so you already have the power supply. Okay, so simple. The gas turbine, open cycle. If you were to have combined cycle like I showed you earlier, so you need bigger space, you need more space, and you need water, seawater, cooling water. Cooling water is a real big one, so you have to take from the sea and you have to discharge to the sea again, and you have to control the temperature. You cannot discharge the temperature more than 40 degrees Celsius. Is against the quality act lah, environmental quality act. Okay, the fish all can die, you know. That's why. Okay, so your selection criteria depend on where you want to plant your power plant. Okay, so then gas, if you want to have gas turbine, you can get gas or not. So for us, no problem, because the gas line is just beside from Segamat, from Kerteh and all that. So we can plant gas turbine. Like Camera Helen, can you plant the gas turbine there? Cannot, because we don't have gas line to Camera Helen. So, but Camera Helen, they can have hydro, okay, because they have a lot of water there, dam. So and the height, they need the height to construct the hydro power plant. Okay, so that is hydro power plant. The answer, to answer to your question, what medium, what the characteristic to use. So that's my answer. Okay, if you are up the hill, is a hydro. In the jungle, you use hydro. Okay, and if you are in the middle of the town, you cannot use I'm not telling you cannot 100% use the combined cycle, because nowadays they have very good cooling system. They use air condenser, air cool condenser, ACC. You can Google and see. Okay, so they no need seawater. So okay, nowadays the technology is there. They can have combined cycle power plant in the middle of the city also. Okay, but you need big fan. Okay, big fan and big space. So that's why all the thermal power plant, the big combined cycle, normally beside the sea or beside the river also. Like Connaught Bridge, Connaught Bridge no sea, only river. So they use river water for the thing. Okay. Any more question?
Okay, thank you, Mr. Mathia. I will pass to Chan Jinwei.
Yeah.
Okay, return to me back again. Okay, Mr. Matthias. So let's proceed to the seventh questions. We know that we have learned a lot of equations in the thermodynamics field. So I want to ask, is there equations that often applied in the calculation of electricity generation in your company? What are the equations that often applied?
Normally, okay. Okay, in power plant, we normally the calculation all by performance engineer. Okay, we normally we don't calculate the performance, but somehow we are involved in the performance. Okay, so by daily operating the power plant, we know. So let's say normally they use Rankine cycle and Brayton cycle. Okay, Rankine cycle and Brayton cycle. So the operators know if the gas turbine inlet supposed to be this much, and it must be that much. Okay, let's say I like to draw.
Okay, no problem, Mr. Matthias.
This is compressor inlet, right?
Yes, Mr. Matthias.
Compressor inlet. So compressor inlet supposed to be 28 degrees Celsius, right?
Yes.
It's the ambient temperature, right?
Yeah.
Okay. And this is P1. P1 is ambient, right? And this one we compress up to P2, T2. Okay, Brayton cycle. Okay. Okay. P2 and T2 depend on your gas turbine design. Okay. Like my compressor, my turbine, it can go up to 15 bar. Okay. 15 bar. All right. And the temperature is about 400 degrees C here. All right. Okay. So this is Brayton cycle. We use Brayton cycle. Okay. So operator, they know if the inlet is 28 degrees Celsius and the P2 supposed to be 15 bar and 400 degrees Celsius. Okay. What will happen? One day the pressure drop to 14 bar or 14.7. What happened? That mean you are underperform, right? This is new one, right?
Yeah.
You underperform. So that means your performance is dropping now. Why? Because your compressor is dirty now, right? At your home also same, right? Your fan, you're inside your room. If the fan dirty, hot. So you have to clean the blade. Okay. It same goes to us. So we have to clean the turbine blade. Okay. Okay. This is the example. Okay. This is Brayton cycle. Okay. This I simplified because you also rushing. And okay. And this is the combustor. So we have T3 here. T3 and T4. I no need to elaborate this. But by this, you understand, right? Okay. So this is how the operator monitor the performance of the gas turbine. Okay, this is one of the example. Okay. So we monitor temperature, we monitor pressure. So we monitor everything here. Okay. That is Brayton cycle. And one more is a Rankine cycle. Rankine. Okay. Let's see. Can see Rankine cycle?
Yes, Mr. Mathia.
Okay. It's a Rankine cycle. And this is end of the condenser. Okay. This one turbine, right? Expansion in turbine, right? Steam turbine, earlier was gas turbine.
Okay.
This is turbine, gas steam turbine. Expansion in steam turbine. So after the work done, the steam will be converted into water, liquid. Okay, full liquid. This is full gas. The dryness fraction is X is 0. Here gas, right? Here fluid, right? Okay, here fluid, 100% fluid. Here 100% gas. Okay, 100% gas. So this is condenser. Okay, and here is evaporator. Evaporator, let's say 231 degrees Celsius. So the operator will observe before entering the boiler, before entering the evaporator, the temperature must be 231. Otherwise, something wrong somewhere. Okay. And in our calculation, do we have m dot?
Mass flow rate, I think.
Again?
Am I right? Mass flow rate.
Mass flow rate, right? Then we times H1, H2, something like that. Okay. This mass, the bigger the mass, higher the output, right? Okay, why? Sometimes M is, okay, what will happen if the M is small? Lower the output, right? Your performance will drop, right?
Yeah.
Okay. How can the M small become small? M is the flow, the steam flow, right? That means you lost your steam, right? And it happened in our boiler also, okay? It happened because leakage.
Oh, okay.
Because of the leakage, or the feed water pump not efficient, okay? And maybe the valve jam or something like that, okay? And also blow down. We do blow down. Sometimes if the water, in the water, they have many much chemical, we have to do blow down. So that once you do blow down, this M will drop, okay? So the operator must monitor all this, okay? And temperature and also pressure, okay? So this is the ideal condition, So you must monitor the pressure. Let's say you want to have 200 megawatt. This is the temperature and this is the pressure. Okay, not all the time. Sorry, not all the time. If you are generating 250 megawatt, example, this is the temperature and this is the pressure. Okay, but again,
May I know how much the pressure that it requires?
okay, my pressure here is 124 bar.
Okay.
124 bar
Yeah.
entering the steam turbine. Okay, and the pressure and the temperature is 540 degrees Celsius.
Okay.
And we have okay, just now I only showed you one. This is HP turbine, HP turbine. This is HP turbine. Can you see?
Can.
Can, and we have reheater again. So we reheat and come down again. Okay, this is one turbine. This is IP turbine. IP mean intermediate pressure turbine. Intermediate pressure turbine. Then we have LP turbine. Low pressure turbine. This one is HP turbine. HP turbine. High pressure turbine. Then this thing. Okay. Okay. So and goes to condenser. So we have three pressure. So we have reheater here, reheater. Okay. So more complicating lah. So that's why I just now earlier I showed you only once. This is what you study in diploma lah. Okay. Then we have a lot of things later. When you go higher and higher, then you can see the what like that lah all. Okay. So don't complicate first.
Okay.
Right.
Right. I
So
think.
this is Rankine cycle.
Okay.
And earlier one is Brayton cycle. Okay.
Yeah. So I think Mr. Mathia just now already answered my next question I'm going to ask, which is
I see.
about Brighton cycle and Rankine cycle.
Okay.
So I think I already understand how we read information from the graph and what's the differences between both cycles. I think Mr. Mathia already answered, right?
Yeah.
Just now Mr. Mathia showed us how it works, how the graph goes with the temperature change or pressure change. So I think there's no questions for us now, and we all can comprehend all the informations that Mr. Mathia trying to convey to us.
Okay.
So I think we can end this interview session now because it's already 5:49. It's hampir 1 jam lah. Sudah macam it's already long. The video duration is already long. So let's call it a day. Mr. Mathia, thank you once again for attending the interview session, and thank you for willing to share beneficial information with us. I think we may leave the meeting now. So goodbye everyone, and have a good day ahead. If there's mistake I've made in this session, so I apologize because maybe I'm not doing well in communications. If there's any mistakes I've done, so I apologize. So I think we can leave the meeting now. Okay. Thank you, Mr. Mathia.
Okay.
And
problem.
thank you, everyone.
Thank you very much.
Thank
Good
you
luck
for-
good luck in your project and future. All right.
All right. Thank you, Mr.
Thank you.
Mathia.
Bye-bye.
So,
Thank you, Mr.
okay.
Mathia.
Thank
Bye.
you, Mr. Mathia.
Yeah.
Yes. Bye bye.
Thank you to the Mr. To because Mr. To yang suggest you for us.
Okay.
Mr. To and also my Dato.
Yeah. Your Dato is my operator last time.
Oh.
Send my regards to him.
Okay.
You no need
Thank
to
you, sir.
send. I will see him later.
Okay.
All right.
Okay,
Bye-bye.
all right.
Bye.
Okay, goodbye, Mr. Mathia.